For our group, the topic of interest is hotel management booking cancellation. One of the best ways for hotels to increase revenue as tourism recovers is to minimize vacancy. Thus, we want to address this problem and effectively help hotel management to decide how to predict whether or not bookings will be canceled based on a wide range of features.
So the motivation behind our project was to determine the best way to predict whether a booking is likely to be canceled based on a set of features. So from a hotel management point of view, this will allow hotel managers to better predict the chances of a possible vacancy. That way, hotel managers can plan to book more guests in advance if a significant amount of current bookings are likely to be canceled. And in addition, we looked at pre-COVID-19 data because tourism is finally beginning to recover. So using pre-COVID-19 data will help us interpret how hotels should approach scheduling in the future. So the dataset that we used came from Kaggle, and originally it had 36 features and 100,000 samples before pre-processing, and each sample came from city or resort hotels from Portugal. And for methodology, our first step was to pre-process the data, and finally we used various classification methods in order to find the model that provided the greatest prediction accuracy. So for our pre-processing steps, the first thing we did was one-hot encoding for our categorical variables. Then we did feature selection. We removed any irrelevant features such as name or credit card number, email, etc. And we scaled any of the continuous and non-categorical data. And then we also removed null entries.
There were many features in our dataset that could be simply reasoned to be irrelevant to our problem. Examples including the last 4 digits of travelers' credit cards. Therefore, we started our pre-processing with simple feature dropping, where we only selected the ones you see on the slide and removed the others. There were also occasions where some variables could be combined to slim the dataset down, an example being how each aspect of the customer's arrival date is separated. We were able to combine these into a continuous day-of-the-year value. Finally, like we said before, we implemented one-hot encoding for applicable categorical values. We assessed all of our models on splitted train test sets, with the accuracies of each displayed on this slide. It is easy to see that overall, for this specific task, the tree-based classifiers outperformed the naive Bayes and logistic regression classifiers by a considerable amount. We have also included the pre-hyperparameter tuning accuracies and post-tuning accuracies for reference, where, for the non-tuned statistics, we did not supply any or supplied random parameters to the sklearn model initializers, in which we will cover now. For our decision tree classifier, we used sklearn's randomized search CV module to search for the best choices with regards to the minimum samples in a leaf and max depth, along with the splitter choice. We were able to obtain an accuracy increase of approximately 1% after tuning the parameters, with no perceivable difference in computation time.
For random forest hyperparameter tuning, we selected a subset from parameters and take out less relevant features such as minimum sample split and bootstrap. Given 300 fittings in total, the result using the best parameters is as above, with close to 86% accuracy on testing data.
We were able to apply many of the machine learning models and techniques learned during this course in an attempt to provide a prediction on whether a hotel booking will be canceled or not. To recap, we pre-processed our data using techniques such as one-hot encoding and built 4 different classification models for this task. Ultimately, the decision tree and random forest classifiers yielded the greatest accuracies. For an interactive demo, we've created an example web page where anyone could access and try out the models we have trained. The URL to access this web page is on the slide. Not all of the features are accessible on this page in order to decrease the clutter and increase usability.